In this video, we will discuss how to determine the half reactions that make up an overall redox reaction. Redox reactions are comprised of two components, an oxidation pathway and a reduction pathway. The reduction pathway is a process that occurs when the oxidation number of an atom decreases. That atom gains electrons. A lot of times you can denote the reduction path by a loss of oxygen by a molecule. Also, the half reactions, when we pull those out, the electron will be written as a reactant. Oxidation, on the other hand, is a process that occurs when the oxidation number of an atom increases. You'll find that that atom loses electrons. A lot of times the oxidation path can be identified by compounds adding oxygen, but it's not always the case. You'll find when we determine the half reactions that the electrons are written on the product side for the oxidation pathways. So what we're going to do is we will write out our oxidation numbers and we'll figure out which atom went up in oxidation number and which one went down in oxidation number. We'll then be able to split the reaction into its two separate half reactions. One reaction that's involving the oxidation of an atom and one that is involving the reduction of an atom. The oxidation half reaction has the electrons written as the products, and the reduction half reaction has the electrons written as reactants. The general process for determining your two half reactions and balancing them independently is first, you need to assign the oxidation states. So you will determine which atom is oxidized and which atom is reduced. You will write out the oxidation and reduction half reactions, including the electrons. Oxidation will have electrons on the right-hand side, reduction will have electrons on the left-hand side of the arrow. We will use the electrons to balance the overall oxidation number between the two sides. You will then balance the half reactions for mass, first balancing all the elements that are not hydrogen and oxygen. Then you will balance the oxygen by adding water to whichever side still needs oxygen. And you will balance hydrogen at the end by adding H+ or the hydronium ion. Make sure you check by counting the atoms in the total charge when you're done that you have correctly balanced each half reaction. So let's get started with our first example. We looked at this reaction when we were first determining our oxidation numbers. So the first thing we're going to do is write down our oxidation numbers. Chlorine is an element, so it has an oxidation number of 0. Iodide is a monatomic ion, so it gets its charge. Oxygen is -2, and then the hydrogens are each +1. The chloride is -1. Each one of these oxygens is a -2. -2 times 3 is -6. One of those is already accounted for, so the I has to be a +5. We will then determine which atoms changed in number, which one went up and which one went down. First, look for the one that went down in number. So, chlorine started out at 0, and it ended up at -1. So this particular pathway, each one of the chlorines picked up 1 electron. Keep in mind, electrons have a -1 charge, so each chlorine added 1 electron. Therefore, this is your reduction path. The number went down, and so the number is reduced. Therefore, this is your reduction path. The other number that changed was the oxidation number for iodine. Iodine started out as a 1, ended up as a 5, and so each iodine atom gave off 6 electrons. And so that would be oxidation. So writing out our oxidation half reaction, we would start, and when you're doing this, make sure you give yourself plenty of room. I minus goes to give IO3 minus. Okay, and then in order to balance our oxidation numbers, what we need to do is we need to add these 6 electrons that came off. And because we have a negative here, that tells us that the reaction, that this half reaction is giving off 6 electrons, and so we're going to put our 6 electrons on the product side. Okay. Now if we compare the left-hand side with the right-hand side has extra oxygen. We need to be able to balance those out. So we will be adding water, H2O, to balance out our oxygen. Because we have 3 oxygen on the right, we will need 3 waters on the left. Now, by introducing water, we've introduced some hydrogen on the left, which we don't have on the right. To balance out the hydrogen, we are going to add H plus ions. On the left-hand side, we have 3 times 2, so 6 hydrogen. So we need 6 hydrogen on the right. Okay, at this point, everything should be balanced. To check, we're going to look at our reactants versus our products for iodine, hydrogen, oxygen, and then the charge. On the left-hand side, we have 1 oxygen, we have 6 hydrogen, we have 3 oxygen, and the overall charge, the only thing that has a charge on it is the iodide ion, and that has a -1 charge. So the sum of the charge on the left is -1. For our products, we have the IO3 minus, so there's 1 iodine there. We have 6 hydrogens, and we have 3 oxygens. The overall charge is -1 from here, -6 plus 6, so we would have a -1. The numbers all work out, therefore this half reaction is balanced. Our next step is to write out our reduction path. So we would start with our chlorine, Cl2. Make sure you give yourself plenty of room. That goes to Cl minus. For this process, balancing out our atoms, we have 2 chlorines on the left, 1 on the right, so we'll need 2 chlorides. Then we had determined already that for each chlorine atom, it's going to be picking up 1 electron. We have 2 chlorines, and so on the left-hand side, in order to balance out the oxidation numbers, we need 2 electrons. Right? So the left-hand side, we have 2 electrons, 1 for each chlorine. On the right-hand side, we have the chloride. There are no extra oxygens, no extra hydrogens, and so we are now balanced. Checking this, we will look at our reactants versus our products for chlorine and then charge. On our reactant side, we have 2 chlorine. Our total charge is 2 times -1, so -2. On the right-hand side, we have 2 chlorine, and our total charge is 2 times -1, so -2. Okay, so we now have our reduction path fully balanced and our oxidation path fully balanced. In future videos, we will look at how we can combine these together to balance the overall redox reaction. Continuing with this process, for one of the other reactions that we were looking at when we were coming up with our oxidation numbers. First, we need to determine our oxidation numbers. So each one of these oxygens will be in -2. -2 times 4 is -8. We already have one of those accounted for, so the manganese will be a +7. Oxygen is going to be -2. The hydrogen will be +1. That's 4 times -2, so that's -8. Plus 2 times 1 is 2, so we have -6. That the carbon need to account for, there's 2 of them, and so each carbon will be a +3. Manganese here is all by itself, so it will be the same as the charge. Oxygen, each one of those is going to be -2, and the carbon here, to balance it out, that would be 2 times -2, so you got to balance out a -2, so carbon will be +4. 4. Okay. Now, first thing we're going to do is look for the one that went down. We're going to identify the reduction path. So if we look, the manganese went from 7 to 2, and so that one is the one that went down in number. Each manganese picked up 5 electrons, so plus 5 electrons. That makes this the reduction path. Our oxidation path, the other atom that changed was carbon. Carbon here changed from a 3 to a 4, so that means each carbon lost 1 electron, making this our oxidation path. Balancing out our oxidation reaction, we have H2C2O4, giving plenty of room, goes to give CO2. First thing we're going to do is balance out our carbons. This right-hand side needs 2 CO2s to balance out our carbon. Okay. Then we got to figure out how many electrons. Now, because this is oxidation, our electrons are going to go on our product side. Each carbon, as we previously determined, is going to give off 1 electron. We have 2 carbons, so this reaction will give off 2 electrons. To balance out next our oxygen, on the left-hand side we have 4, on the right-hand side we have 2 times 2, so we have 4. That part's balanced. Finally, we balance our hydrogen. On the left-hand side we have 2, on the right-hand side we have none, so we're going to add 2H plus to balance everything out. If we check to make sure that everything's balanced, we can look at our reactants versus our products for carbon, hydrogen, oxygen, and charge. On the left-hand side, we have 2 carbon, we have 2 hydrogen, we have 4 oxygen, and our overall charge is 0. On the right-hand side, we have 2 carbon, we have 2 hydrogen, and we have 2 times 2, 4 oxygen. Overall charge, -2 plus 2 is 0. In our reduction path, we have MnO4 minus, giving ourselves some room, goes to Mn2 plus. First, balancing out our manganese. On the left-hand side we have 1, on the right-hand side we have 1, so that's balanced. For each manganese, as we previously determined, it will be picking up 5 electrons, so that goes on the reactant side, plus 5 electrons. Okay, now we're going to balance out our oxygen. On the left-hand side we have 4, on the right-hand side we don't have any, and so we're going to add water, H2O, and then to balance out our oxygens we're going to need 4 of those. By introducing water on the right-hand side, that means that we have also introduced some hydrogen. On the left-hand side we don't have any, so to balance that we're going to add H plus. Now, if we have 4 waters on the right, that means we have a total of 8 hydrogens on the right-hand side. We need to balance out those 8 hydrogens, and so we'll need 8 H pluses. So this should now be balanced. Checking our balance, looking at our reactants and our products, we have manganese, we have oxygen, and we have hydrogen, and then we also have charge. Okay, manganese we have 1 on the reactant side. For our oxygen we have 4, we have 8 hydrogens, and then the sum of our charge would be -1 minus 5, so that's -6, plus 8 would be plus 2. On our product side, first make sure that it's balanced. So manganese we have 1. On the product side we have 4 oxygen, we have 8 hydrogen. Now, to look at charge, the only thing that has a charge on the right-hand side is the manganese, and so it will also be plus 2. Right? So both our oxidation path and our reduction path are now balanced. We will now do a final reaction. This is the last one that we had done previously when determining oxidation numbers. So first step, we got to redetermine our oxidation numbers. So oxygen will be -2 each. The hydrogen will each be +1. So that's -2 plus 1 is -1 times 4 is -4. One of those is already accounted for, so the chromium will have to be a +3. Here, our oxygen is -2. One of those is already accounted for, and so the chlorine will have to be +1. Oxygen -2. -2 times 4 is -8. Two of those are already accounted for, so our chromium will have to be +6. Here, it's just the same as the charge. Okay, first thing we do, look to see which one decreased in value. So our chlorine went from 1 to -1. So each chlorine atom picked up 2 electrons, plus 2E-. So that is our reduction pathway. Our chromium started out as +3, went to +6, and so this one, each chromium atom lost 3 electrons, and so this is our oxidation path. Writing out our oxidation half reaction, we have CrOH4 minus. This will yield CrO4 2 minus. Balancing first our chromium, we have 1 on each side, so that part's balanced. Adding in our electrons, for the oxidation path, the electrons are products, so this will be plus 3 electrons. Okay, next we balance our oxygen. On the left-hand side, we have 4 oxygen. On the right-hand side, we also have 4 oxygen, so that's balanced. The last one is balance our hydrogens. On the left-hand side, we have 4 hydrogens. On the right, we don't have any, so we will add H+, and we will need 4 of those for everything to balance out. So at this point, it should be balanced. So comparing our reactants and our products for our oxidation path, we will look at chromium, oxygen, hydrogen, and charge. On the reactant side, we have 1 chromium, we have 4 oxygen, we have 4 hydrogen, and the overall charge is -1 from our ion. On the right-hand side, we have 1 chromium, we have 4 oxygen, we have 4 hydrogen. Our overall charge is -2 minus 3 plus 4, which gives us -1. So our oxidation path is balanced. To our reduction path, we have ClO minus goes to give Cl minus. Okay, our first balancing out our chlorine, we have 1 on each side, so that's balanced. The chlorine are picking up 2 electrons that we previously determined, so that will go on our reactant side, plus 2E minus. Our left-hand side, we have 1 oxygen. Our right-hand side, we don't have any, so we will need to add water. And we'll be adding just 1 of those, so 1 water. That introduces 2 hydrogen on the right. We don't have any on the left, so we'll need to add H+, and we'll need to add 2 of those to balance out the hydrogen. Our reaction should now be balanced. So if we look at our reactants and our products for chlorine, oxygen, hydrogen, and then charge, our chlorine on the reactant side, we have 1. We have 1 oxygen, we have 2 hydrogen, and then our overall charge is -1 minus 2 plus 2 would be -1. On our product side, we have 1 chlorine, 1 oxygen, 2 hydrogen, and our overall charge is just from the chloride ion, so that would be -1. In a subsequent video, we will be doing a similar process and then looking to see how we can combine these two together to come up with a balanced overall reaction under both acidic and basic conditions.